Hello, everyone, and welcome to the Energy Movement platform. Today, I would like to talk with you about flexibility of pneumatic drives. We know pneumatic drive as a quite rigid technology. So, if we talk about the actuators, for example, and we take a linear actuator under the same pressure level, it will always perform always the same task. However, in the era of new machines, of a new technology, and the flexibility that we require from the production, we expect a certain changes of the technology too. Why it is important in the terms of energy efficiency, but also the performance, I would like to talk with you today. So, just for you to remind, cylinder, pneumatic cylinder we use to perform a certain task. It's a linear actuator, and we use it when we need a certain force, or we need to move a certain mass, or we need to have a velocity required for the application, and we can use it horizontally, vertically, or at the mountain angle of 45 or 30 degrees. And the moment we choose this actuator, we also need to remember that the consumption of the air depends on the pressure level and on the filling volumes of this cylinder. So we usually have a fixed pressure levels on the regulator of the machine, and then we have a fixed cylinder that we cannot change if we, in case we need to change for different applications. So it will always have exactly the same consumption. And this is very important when we talk about the energy efficiency because pneumatic drives, most of pneumatic drives, I would say 90% are oversized nowadays. And this is a typical example that we require 600 newtons of force with a certain velocity. And the cylinder that could actually work for this application would be cylinder with 40 millimeters. However, very often we take a bigger one. It's just a rule to get some security. And then the consumption there is already 30% more. So we actually don't need the biggest cylinder, but very often they're so oversized that the consumption increase, and we actually can save a lot of energy and a lot of compressed air, and to have better performance technology rather than 40 millimeters. But what if we need not a 600 Newton? What if we need 700 Newton or 800 Newton? In this case, we also will get the oversized cylinder, well, oversized just because it's the only available size now. And what should we do in this case? In this case, we can either look for the alternative cylinders with alternative size, but of course it's hard to change it every time if we change the task there. But we also can think about the smart technologies that can adapt to this. And if we talk about the practical application, there are some machines, the woodworking machines, for example, that need to press various different boards. So with to the thicker board we need the require higher force, smaller board we need the smaller force. And in this case, for example, if we use only one machine, we always will get the biggest cylinder for the bigger one, even if we only need 1% of the time, or 10% of the pieces will come for the wider board. For all other tasks, it means we will feel uh, more compressed air, and we will get a hugely oversized system. So it's all about different forces, it's all about different moving times, and it's all about flexibility. But when we cannot change the pressure level in front of the machine every time we change the piece there, what can we do? So to go into the technologies that I want to talk today with you, we need to see the theory and the pressure profile, and as well as velocity profile, and just to remember for what we use pressure and volumes, compressed air in those kind of applications. A typical profile, velocity profile, is divided in 5 stages. The first stage, it's usually nothing is happening there, and we need to fill pipes and as well as pressurize the chamber A of the cylinder drive. In the second profile, in the second stage, the cylinder overcomes the dry friction and the depressurization in the opposite chamber starts. When the pressure difference achieve a certain level that the cylinder can overcome the dry friction as well as other frictions, then the cylinder starts to move against the uh, mass, or maybe against with a certain force that is required there at the cylinder. And in this stage, we achieve relatively constant velocity. And then finally, cylinder comes to the end stop. And here we have an end cushioning system that we need to adjust in case to have a smooth end of the stroke. If we look the same velocity profiles and pressure profile and also volume profile, so here you see this spike here, it's basically the filling of the tube and dead volumes here of the cylinder. And this part is basically the this part. So what is happening when we actually need the stroke? Logically, we can see that to avoid these spikes here, we need to locate this valve directly onto the cylinder. However, let's see what we actually use. For this movement, we need only the pressure difference. We don't need this absolute pressure here. So we need this pressure difference, and this pressure difference is also achieved thanks to the settings of the throttle, of the opposite throttle here. And here, in terms of the volume, we need only this part. So we don't need this part here, and we need this part here to be able to move this cylinder. Logically, we can think that we provide more energy to our system that we actually need. And this is true. So in pneumatic drives, the day how they designed nowadays, we don't use expansion energy there. So yes, we have the compressibility of the fluid, so of the air. It we can compress it quite easily, but at the same time it also expands. And this expansion energy, we don't use it. It means that at some moment we actually can close the feeding of the system of the compressor into the cylinder and use the rest of the energy to adjust it to have this pressure difference to perform the task. And those kind of technology, they are now available, and they can actually adjust using just one system, one standard cylinder, adjust this input energy to different forces, to 200 newtons, 500 newtons, or 10,000 newtons. We still can use the biggest cylinder, but however, we can limit the volume flow rate that we put in the cylinder according to the task. So this technology called the PCC Blue cylinder, available by a company called Mother from Germany, and it's a standard cylinder with the standard sizes, and it has a special add-ons. It is a smart valve with integrated algorithms there that can limit the input to the system. And this is, we can easily calculate the economics of this and understand actually how much it can save energy and money for the machine, and as well as for the end user of the machine. So imagine that we take the cylinder with the standard diameter 50 millimeters under the pressure of 6 bar, and it provides the standard force of 1000 Newton. This is the flow and cost that we can achieve with this. And then we get the PCC Blue cylinder, the same idea, but we need also there 500 newtons and 200 newtons. It also adjusts the flow according to this, and of course it has the considerable cost saving. In case we need 1000 Newton for the bigger application, as for example for those boards that I showed you at the beginning, only 10%. 70% of 500 newtons and 20% of 200 newtons, the savings can be easily calculated there. In this case, for standard applications, we will take only the biggest cylinder. It's going to be almost 900 euros for this. And if we take the smart cylinder by PCC Blue, it will get the considerable savings around 500 newtons for this. To calculate each case, particularly for each application, I recommend you to go and download Direct and EasyCast. We integrated their PCC Blue by Mother in our software, and you can calculate the savings there, applications, as well as the all parameters. And in this case, it's quite easy. So all the parameters can be calculated here, but just go and download EasyCast. And I would like to invite you once again to Energy Movement platform, where we connect end users of compressed air. There you can learn more about the technologies that are available on the market. You can meet also their experts that can help you optimize system from the generation, supply, until the end use of this. And as well as we're happy to see experts and technological partners there to drive pneumatics more sustainably, make it more flexible as well as more efficient. Thank you. It was Elvira Rakova, and I see you in the next technology overview by Energy Movement.